on the first two things on this slide, remember the dot product, we multiply first times first, second times second, add them together. And then the angle between, we said the cosine of theta equals the dot product of these over the magnitudes, the product of their magnitudes. Or take it a step further and do the cosine negative 1 of that. U dot V over the magnitude of U times the magnitude of V. So all three of these, you'll see on your test as individual questions. So just make sure you know how to do all that stuff. Actually, not the straight up dot product, but you need to know the dot product to do the angle, right? All right, then number 3 said determine if they're orthogonal. And remember, this is the same thing as saying perpendicular. Okay, if it just said that, if it just said orthogonal, it was yes or no, then I could probably find, you have two options. One is find the dot product and see if it's 0. The other is find the slopes of these two and see if they are opposite reciprocals. So if I did the dot product, it would be 7 times 2, which we had already done, plus negative 3 times 8, which would be 14 minus 24, and that's negative 10. If this is 0, then they're orthogonal. But on your test, it's going to be like it was in the examples where it says, are they parallel, orthogonal, or or neither? So you want to also test for that. And I think when you do that, it's easier just to find the slopes. So the slope of U would be negative 3 over 7 because it's change in X and then change in Y. So we do second over first. And then for V, it would be 8 over 2, which is 4. And these are not opposite reciprocals, and they're not the same, which would be in neither scenario. Okay. Again, that's like the only multiple choice question on your test, but that's what it looks like. Questions on that one? And again, everybody's good on the homework. So last call on homework questions. All right, the last section. All right, 3 says to find the angle between, right? So this is where I have to do, oh, you just missed the degree symbol.
Oh, right.
Yeah.
No wonder. I was like, I swear it was right. I did it like
Yeah, I'm sure that's what's happening. Jacob, was that yours too?
No.
Okay, so you want to give me your numbers, Jacob, and I'll do yours?
Oh, I know it was.
Okay. Erica, was it the same thing?
Yeah, I think so. But
Okay.
could you just go over how to put it into the calculator?
Sure. So do you want to give me your numbers?
Yeah, so I got 18.43, which that's not, well, I got 22.83, but I started like second guessing myself when I didn't say that it was right.
Okay, what's your U?
I got 5.
No, like what's the U? The whole. It's this one, right? It's number 3 that you're asking about?
Yeah, so it's 3, negative 4, and then the V is 1, negative 3.
Okay, oh, so I minus 3. Okay, so that was the difference. Okay, so this would be 3, negative 4, and then this would be 1, negative 3. So the dot product would be 3 times 1 plus negative 4 times negative 3. 3 plus 12, which is 15. That's going to be your numerator. And then the magnitude of U would be the square root of 3 squared plus 4 squared. This is a triple, but it'd be 9, 16, 25, which is 5. And then the magnitude of V, square root of 1 squared plus negative 3 squared, 1 plus 9 square root 10. So when you type that in the calculator, you're going to do cosine negative 1, open the parentheses, well, it will open the parentheses for you, 15 divided by, and then you have to group together the 5 and the square root 10. So open the parentheses, 5 times the square root of 10, and that's the 18.43.
Okay, I know there was a question that it had 2 square roots. Should we like...
So for that one, if you have, do you have this calculator? Which one do you have?
Yeah.
So when you do that, it's 15 slash, let's say it was like, say I kept it as square root 25, because you could have, right? When you hit square root, it opens the square root and the parenthesis, or it puts it underneath. You can actually write 25 times 10 and keep it all underneath 1 square root.
Oh, okay.
And you can keep it like that.
Okay, thank you.
Okay, you're welcome. Olivia, 4?
5.
5. Okay, so graph the vectors was first. This would be negative 10, negative 5, and this would be negative 4, 2. So if I had a coordinate grid, because this is what's going to happen on your test. You're going to have a coordinate grid that you have to do the UV, okay? But I'm going to give it to you on an answer sheet ahead of time. I'm going to try to finalize that today. I was still going back and forth on one thing, but I'm going to try to finalize that today so that you can print it. If you're in person, I'll have it printed for you. So negative 10, negative 5 would be the first vector. This is u. And then negative 4 up 2 is the second vector. That's v. Then it said to find the, so that was, I just covered it up, but that was the answer underneath it.
Yeah, I just didn't know how to do the angle.
Okay, then it says find the angle between. So it'd be cosine negative 1. U dot v is negative 10 times negative 4 plus negative 5 times 2. So I get 40 minus 10, that's 30. That's the numerator. Then I have to do the magnitude of u, square root of negative 10 squared plus negative 5 squared, 100 plus 25, square root of 125. If I was giving that as an answer, I'd simplify it, but because I'm typing that in the calculator, you could leave it like that. And then the magnitude of v, square root of negative 4 squared plus 2 squared, 16 plus 4, square root of 20. So when you type that in the calculator, I could do cosine negative 1. It's going to open the parentheses, 30 divided by, start my square root and keep both the 125 and the 20 underneath it. 30 divided by square root 125 times 20, and you get 53.13 degrees. So as far as like answer format, obviously on Canvas, you won't put the degree symbol in, you'll just give me the angle. Be really careful with the rounding. Like if it says 2 decimal places, I'm going to be really, really picky about those. These should be exact. So there's no like rounding give there like there was with law of sines and cosines, because this is straight up. You shouldn't be rounding that at all until you get all the way to the end. Any other questions from the homework that didn't get answered there? In this chapter, which is 6.5, and it's called the trig form of complex numbers. So there's really only like 3 main topics in this section, and you will get like a question on each of those main topics. It overlaps a little bit with what we were doing before, but it's a lot different. So a complex number is what? Do you remember? It's imaginary, so it's going to involve an I, okay? So we are going to take a complex number and convert it into trig form, or take a trig form and convert it into complex number. And we're also going to graph these, so we start there. So the complex plane looks almost identical to a coordinate grid, except that the x-axis is the real axis and the y-axis is the imaginary axis. If you remember standard form, it was a plus bi. This would be your x and this would be your y when I plot it, okay? So it actually goes in the same order that we're used to. This, when we plot these, they are coordinate points. So it's just a point and not a vector. Like the other ones would be a line, this would just be a coordinate point. The absolute value of a complex number is found by doing the square root of a squared plus b squared, which should look familiar. What do we use that for? Magnitude. So the absolute value of an imaginary number is the same formula as the magnitude of a vector. The difference is this is not length, because we're plotting a point, so you can't find the length of a point, okay? It's just the absolute value of it. So it is defined as the distance between the origin and that point, but it's actually just, we're not drawing a line there. We're finding just the absolute value, square root of a squared plus b squared. A is the number that doesn't have the I, B is the number that does have the I. All right, so this one says plot and find the absolute value. So the first thing I'm going to do is take my imaginary number that's in standard format and convert it into a point. So if I had negative 3 plus 6i, what does that look like in coordinate point form? All right, I'll help you with the first one, but then somebody's going to answer me the next time. This would be negative 3, 6. So I just take the number that doesn't have the I, and that's the first term. I take the number that does have the I, but I don't keep the I just take the number part, and that's the second one. So on my coordinate grid, remember this is the real, and this is the imaginary. So I'd go back 3 and up 1, 2, 3, 4, 5, 6, and I plot just the point. Do not connect it with a line. It's just a point. The absolute value of this would be the square root of A, which is negative 3 squared, plus B, which is 6 squared. I get the square root of 9 plus 36, which is the square root of 45. And 45 is 9 and 5, so that becomes 3 root 5. So this will be one of the two things that you graph. Okay, remember I said it last week, but you're going to have like a U and V graph, and you're going to have to add them together or find 2U plus V or 3U minus 3V, whatever it is, you're going to have to graph that on your answer sheet. And then you're also going to have this on your answer sheet. This will be in parts though. So on Canvas, you will write in the absolute value, which in words would be 3 SQRT5, like that. No spaces, back to that, okay? And then on your answer sheet, you'll actually plot the point. So I'll post an answer sheet that has a coordinate grid. I didn't want to do it before and confuse everybody. I'll post an answer sheet that has a coordinate grid, and then also one that has like a UV grid, because you'll have to graph that too. For folks here, I'll have them printed. All right, then B says Z is 2, negative 4I. So what's the coordinate point? 2, negative 4. That means I'm going to the right 2 and down 4. I'm going to plot that point. And again, it's just a point. And then the absolute value is the square root of 2 squared minus negative 4 squared. 4 plus 16, square root of 20, which is 4 and 5 are 2 root 5. 2 SQRT 5. So this, obviously, if it was open-ended, you would just keep it like that. On your website, you'll write it like that. But on the Canvas question, it would be formatted like this. Easy stuff, right? Especially if you can write out a reference sheet and tell yourself what the absolute value is. Previous years, you actually had to remember that. All right, the third thing, because if you do the plot and the absolute value, is this, which is the trig form of a complex number. So the trig form of a complex number takes your complex number, which is going to have the number and the I, and it converts it into a coordinate point. And the way we do it is the radius times the cosine of theta plus I times the sine of theta. God bless you. And the I can be written on the front, or it can be pushed to the outside, or to the end, okay, of the sine of theta. You just want to be careful not put it, like not take the sine of that angle. So first we find the radius, and the radius is, again, same formula, square root of a squared plus b squared. And then we have to find theta. So there's two parts of this. 1, find the radius. 2, find theta. And we find theta the way we found it with our force. We take, if we could draw a triangle, we would draw a triangle. The opposite would be your B. The adjacent would be your A. And to find the angle, we'd do the tangent of that would equal opposite over adjacent. And then we inverse tangent that. So to get to actual theta, we do tan negative 1 of B over A. If it's unit circle base, you'll keep it exact, and you'll give me a unit circle angle in radians. If it wasn't unit circle base, then you could use a calculator. Question on your test will be unit circle base. So this is, I told you last week, but I told you there was going to be another reason we needed the unit circle. This is it. Okay? So what's tricky here is that, remember, tangent repeats. Like you have the same value for tangent in the first quadrant and the third quadrant, and in the second quadrant and the fourth quadrant. But there's only one right answer. So how do you figure out which one it is? And that comes from the location of the original angle. Of the original point. So we're going to plot that point. You're going to figure out where it is. And then from there, you'll know which quadrant angle to grab of tangent. So two parts. One is find the radius, square root of a squared plus b squared. Second part is find theta using your unit circle and the location of the original plotted point. All right, so this says write the complex number in trig form. So the first thing I'm going to do is convert this into AB, right? So coordinate points. So if it's 3i, what's my coordinate point? 0, 3. Remember, the I always comes second. So my radius is the square root of 0 squared plus 3 squared, or the square root of 9, which goes back to 3, which should make sense if I only go 0, 3. My point is here. So it would be a straight distance, a vertical line straight to the origin, which would be 3. The second part is that the tan of theta equals b over a. So the tangent of theta equals the b, which is 3, over a, which is 0. What happens when I take 3 and divide it by 0? What happens when you divide anything by 0? Good, it's undefined. So this is a perfect example of something that you will not be able to use a calculator for. I can't undefine something in my calculator, right? But if I know my tangents on my unit circle, and I should remember that there's 2 places where on my unit circle my tangent's undefined. Would be to have my unit circle for the test, and I would add on my tangents, okay? So here it's 0. Here it's root 3 over 3. Here it's 1. Here it's root 3. Here it's undefined. And the same thing happens down here, except that it's negative. Negative root 3 over 3, negative 1, negative root 3, back to undefined. You can go all the way around your unit circle if you want and add them on for your test. I'd probably advise it because there's going to be times in which we're going to have second quadrant and third quadrant angles for a question like this. So technically, if I look at what's on my graph right now, my unit circle right now, there are 2 places where tangent's undefined, right? But there's only one right answer here, so how do I know it? Maria suggested flipping a coin. I mean, you could do that. That is unadvisable. That's a 50-50 shot.
From our graph?
Good. From that original point. So because 0, 3 would be up at the top, I'd know to pick that top angle instead of the bottom one. Does that make sense? And what's the top angle in radians? Pi over 2. So theta is pi over 2. So the way we write this is the radius times the cosine of theta plus I sine of theta, or sine of theta I is fine. It's just that you can't group theta and I together. Those are separate. So I would do the radius, which is 3, times the cosine of pi over 2 plus I times the sine of pi over 2. If I wanted to check this, I could, right? Because that's my answer. This is the answer. It stays like that. If I wanted to check it, I could say, okay, the 3 cosine at pi over 2, what's the cosine at pi over 2? What's the x at pi over 2? 0. What's the sine at pi over 2? 1, so it would be I times 1. I could distribute this in. 3 times 0 would be 0. 3 times I times 1 would be 3i. Take that, convert it, and you've got your answer. Or your question, actually. I mean, not convert it, simplify it, and you've got your question. So that will work every time. If you get to the end and you've got a couple extra seconds, you can always check it by going back to by simplifying it, actually figuring out what the sine and the cosine are at those angles. And they'll be unit circle based, so you can find them.
Oh, so the end part with the 3 cosine pi over 2 is just a check?
This is just a check.
Oh, yeah.
This is your answer. Yep.
How do we know the radius?
Square root of a squared plus b squared. Yep. Questions on that one? One more. See how far you can get on your own. Try it on your own. All right, so the first thing I would probably do is actually plot it so that you have an idea of what you're working with the entire time. So -2 means I'm going back 2 and down 2. Okay, so I know that coordinate point's in the third quadrant. First of all, that helps me with my tangent angle. Then I would find the radius. So r equals the square root of a squared plus b squared. This would be -2, -2. So it would be the square root of -2 squared plus -2 squared. Square root of 4 plus 4, square root of 8, which is 2 root 2. So there's the first part. Second part, tan of theta would equal -2 over -2, and from that I get what? +1, so I want to tan -1, 1 to get theta. So if I was to look at my unit circle and I know I'm in the third quadrant already, which angle am I grabbing? 5 pi over 4. Theta would equal 5 pi over 4. And so my answer is the radius, 2 root 2, parentheses, cosine 5 pi over 4, plus I sine 5 pi over 4. So if I'm typing that out, think about what it looks like. It's so yucky. But think about what it looks like when you type that out, right? It would be 2 SQRT 2 parentheses cosine 5 pi for pi over 4 plus I, just regular I, sine 5 pi over 4. So homework, obviously this is fine, but quiz on Canvas, that's how you're gonna have to type it in. Yes, I
don't know what this applied to, but wasn't tan only in the first and fourth quadrant?
so that's when we did inverse, and that's when we had to restrict it because it was an inverse. I don't know if you remember. We had to restrict it so that it would pass our horizontal line test because we were looking for an inverse.
So we're doing that now? No,
we're not looking for an inverse now. Yeah, so that it wouldn't be 1-to-1. So you use your whole unit circle like we did when we did our, we only restricted it when we did equations because it would be a duplicate answer, not because it's wrong. I don't know if that makes sense. But when we did the ones where we actually just solved the equation, there would have been the whole unit circle. You just didn't have to repeat it because it happened every half circle.
Okay.
All right, questions for me on anything 6-5 related? Because that's it. Short, sweet, easy section, okay? The test right now is 15 questions. I'm tweaking the timing on it right now, so I wouldn't say that it's going to be set in stone that way, but that's how it is. We can start, like, if you want to start, like, thinking about, we can build this together tomorrow, but, like, tomorrow's early release, too, so keep that in mind. 6-1 was your law of sines. 6-2 is your law of cosines. The law of sines also had your area of oblique. Which is 1/2 AB sine of C, that one. Okay. The law of cosines had your Heron's formula, which is where you find the s and then do the square root of s times, square root of s minus a, s minus b, s minus c. All that came from 6-2. Then the 6-3 was the basics, the intro into vectors. And that's your component form, magnitude, what came next? The horizontal and vertical component. Adding, subtracting, scalar multiple, and graphing. Six four was dot product, angle between, applications of dot product, like if I had 2.u.v, something like that, you could keep going. Victor, stay with us. And then 6.5 is what we just did. So converting from trig, no, actually from complex. No, it's trig to complex, sorry. Complex to trig. And then graphing and absolute value. So tomorrow we can go back in and kind of fill in like the formulas and stuff on this, but this is basically the general overview. The good news for those of you that struggled on timing on your quiz is there's only one law of sines, one law of cosines. There's only one word problem in those sections instead of both. There are both areas. And then the other word problem comes into play on that horizontal vertical component. So word problem here, and then one word problem from law of sines or law of cosines. And again, depending on your version, so it depends on what you get. There's two graphing questions. One here with like a u plus v or a 3u minus v or something like that, where I'll give you the graph of u and v and then you've got to do it. And then the second is here when we're graphing our complex, which is literally just a coordinate point. You're going to get your calculator the whole time because it's like intermittent what you need it for. You obviously need it for the vertical component and the horizontal component. You need it for your angle between, and then you need it for the law of sines and law of cosines at the beginning and the areas. So you'll get all that. You'll get it for the whole time. I would also make sure I have my unit circle. So anything like previous that would be, I would add that on there, okay? Questions for me on like logistics or anything like that of the test? Again, right now it's 15 questions. I think that's where I was at. I'm going to make sure that the timing is good on it. Like I'll actually sit down and take it. So the timing is good on that, and I might tweak it a little bit. And the point value will be on the individual questions because it's going to fluctuate. Something that has like 3 parts to an answer is going to be worth more than some short, quick question like adding two vectors. Watch your format on like the adding and the subtracting. I would say like if it's obviously in component form, remember with the brackets. So you don't have to type in any brackets. That's one thing. No matter what your answer is, if it was like this, then I gave just that as the answer. I think I tried to give both, but I did use the little ones that are on your keyboard so that you can do it. But if it's in an IJ format, remember you got to give it in IJ format. So just keep that kind of stuff in mind. All right, I'm going to let you work. So you've